Now that we know the Pythagoras Theorem and Sohcahtoa, we can use them to find missing elements. If you want to refresh your memory, watch these videos. Assuming that we know that triangles ABC and BCD are right-angled, AB equals 12, AC equals 13, and BCD equals 30 degrees, can we find the length of the line sector DC? We don't have enough information to find DC from the triangle BCD because we only know one angle and none of the lengths of the sides. So our first step is to find more information about this triangle. We already know all the angles, so we need to find one side, and after that we'll be able to use Sohcahtoa ratios to find the other sides. Let's look at the triangle ABC first. We already know two sides, AB and AC, so we can find CB using Pythagoras Theorem. Based on Pythagoras Theorem, we get that BC squared is equal to the difference between AC squared and AB squared. So BC equals 5. Now let's go back to the triangle BCD. We have just found out the length of the side BC, and we know we need to find the side DC. What's the ratio between them? We know the angle BCD is 30 degrees. BC is hypotenuse and DC is adjacent to angle BCD. So the ratio between DC and BC is simply the cosine of the angle BCD, which we know from the Ka part of Sohcahtoa rule. As a result, the ratio between DC and BC is the cosine of 30 degrees. So DC is equal to the product of BC and cosine 30 degrees. Success! Let's summarize. To find any element of the right triangle, we need to know at least one of these things: the length of two sides, or the length of one side and one acute angle. If we know two sides and are looking for the third one, we can use Pythagoras Theorem. If we know the side and the angle and are looking for the other sides, or if we know the sides and are looking for the angle, we can use Sohcahtoa ratios. If we don't have enough information, we need to look for the elements that can be found from other shapes. It's not very obvious sometimes, but that's where you can do your maths magic. Give it a try. Pause the video and try to find the length of MN from this diagram. How did you do? So Km equals 15 by the square root of 3, so NL equals 12. To find MN, we first need to find ML. It can be calculated from the triangle KML. Using Sohcahtoa rules, we know that ML equals Km times by the tangent of the angle MKL, which is equal to 15. Now, since we know two sides of our NLM triangle, we can use Pythagoras Theorem to find the length of MN, which is 9. That was easy, wasn't it? Spoiler alert, there are two more powerful rules, the theorems of sine and cosine, that give us the ability to do the same tricks with any triangle, not necessarily the right-angled ones. You can find them in this video.
If you liked the video, give it a thumbs up and don't forget to subscribe. Comment below if you have any questions. Why not check out our AddyESchool app as well? Until next time.